Good afternoon and welcome to the Sustainable Materials Management Webinar Series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen and I'm the Program Manager for the Market Center and will serve as your moderator today. We would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series, and Lisa Ruggiero and Laura Flagg of the National Recycling Coalition for assisting with the RMC with webinar promotion and technical support. Today's webinar focus is on sustainable packaging standards and goals. Our presenter today is Jenny Macaluso, who I'll introduce in a moment. Following the presentation, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you're experiencing any technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And now I'd like to introduce our presenter. Jenny Macaluso is a senior packaging scientist at Burts Bees, headquartered in Morrisville, North Carolina. Jenny received her Bachelor's of Science degree in packaging from Michigan State University. She began her career with Burts Bees and has been working since that time to drive and support the Burts Bees business through her packaging work in the lip care category and sustainability initiatives. Jenny has been and continues to be the lead packaging developer for lip care and color innovations for Burts Bees. She's an integral participant in the packaging standard. Jenny is also a member of the Institute of Packaging Professionals and the Society of Plastics Engineering. And I'll turn it over to you, Jenny.
Thank you, Wayne. I first want to thank everyone for taking the time out to join in today's webinar. As Wayne mentioned, I'm a senior packaging scientist in the research and development group here at Burts, and I've been highly involved in our lip business for the past 3 years. Those of you who are not familiar with Burts, we are a natural personal care company, but most widely known for our lip care and lip color products. With sustainability being a hot topic of conversation in our world now, many consumer good companies are starting to develop models and guidelines for packaging design, really focusing on how to get smarter about packaging and the waste it produces. So today I'm going to give you a high-level overview of our packaging standard and what we are doing. Here at Burts, we believe nature has the best answers and are truly inspired by its resourcefulness. Unfortunately, our products require packaging, and until there's a day when we can transport, keep our products safe, and ensure consumer delight without packaging, we'll require a standard to design to. Currently, we use this standard as a guide for making packaging decisions, and the standard is informed by biomimicry. So just as nature strives to balance itself, we have to be conscious of packaging design, development, and production, and we're also constantly balancing performance, cost, and sustainability. The standard has clearly defined sustainability thresholds and an acceptable materials list, which we do not veer from. And if we do veer from our own defined threshold, it is because better solutions are not commercially available or because they're not commercially available, not because of aesthetics or cost. Our standard is also aligned to and upheld by all functions in our business. And it's governed by our leadership team. So if there are exceptions that have to be made to the standard, the Burts Bees general manager must approve. So we've developed 7 principles that our packaging group uses as a guide when we're designing packaging. So first we start with building the sustainable packaging at the point of concept. So once we charter a project here at Burts, we automatically start designing sustainability into that product. So to elaborate on this point, I've been working on a custom package for a product that will launch towards the end of this year. And from the very beginning of that project, I first had to ask myself, how can we make this entire package out of the same material to help ensure it can be recycled and include a high amount of PCR content? And to be honest, it was a huge challenge for me because the inner workings of this type of package are normally made from a resin that's more rigid like ABS. And to design these components, it had to be right in order for it to be made from a softer resin that's more recyclable like polypropylene. But we were able to achieve a 100% polypropylene package that contains 60% PCR. And unfortunately, I can't go into detail on the package type at this point in time, but most packages that are in market, that are like this in market, are not usually made of one material and don't normally contain a high amount of PCR content. So I was really excited about this, and it goes to show that it can be done if you start to think about sustainability up front. We also looked at the lowest impact design while keeping in mind the product quality, safety, and performance, as well as how to maximize the recovery of the material and how to include recycled content. for instance, PCR content and choosing the right materials we know that can be readily recycled in today's market. We also try to optimize material usage and selection by designing the right size package and the right materials. But we also must keep consumers in mind when we're during the design phase. They are the ones that interact with the package at point of sale and will ultimately be the ones to dispose of the package. Designing a package that's easy to recycle will hopefully ensure the package does get recycled. This includes picking a continuous thread closure over a snap-on closure so the consumer can easily detach the bottle from the closure if needed. We also must keep customers in mind when designing packaging. For instance, what packaging is required for transportation? How can we design a package that gets products on shelf easier? And lastly, we also must not forget about manufacturability by minimizing energy, touches, and costs. So now I'm going to get into more of the meat of our standard and what we use to make decisions every day. We have set pretty lofty goals for ourselves from both the materials and post-consumer recycled content standpoint, and we strive to achieve these and exceed them when possible. Of course, there are instances when our packaging may not meet all of our standards, but this is our ideal state, and as there are continued innovations in materials and collection techniques, we will continue to evaluate and update our standards to accommodate. A lot of our standard is also based on the APR guidelines for their design for recyclability standards as well. The materials on our preferred list have been chosen for a few reasons. They're highly recyclable in today's market. They're able to contain a high amount of PCR content, and the PCR content is also readily available. And the material has an overall low environmental impact to the people or planet. So preferred packaging materials are aluminum, steel, paper, so paper products like paper board. There's also a newer product out there called paper foam, which is an injection molded starch product that actually can be recycled with paper. We use a lot of corrugate, we use a lot of polyethylene, or number one, polyethylene terephthalate, high density polyethylene, glass, polypropylene, films with PCR. And we also have bio-based resins on our list. This refers to the polyesters and polyethylenes produced using the byproducts from sugarcane and other agricultural processes. We currently do not use this newer technology in any of our packaging today, but as the technology develops and becomes more popular, we have included it in with our current standard. The materials on our should not use list have been placed on this list for a variety of reasons. One, they cannot be made from recycled material. They are not readily recycled in today's market. They have very limited to no PCR available, and they present a potential human health or negative environmental impact. I'm not really going to read through every single one of these because this list actually goes on for a few more slides, but you can see the materials like polystyrene and polyurethane are on our list. We have included LDPE on here because of the limited recyclability and availability of PCR, as well as the mixed materials laminates for the same reason. Colored or tinted PETE has been placed on our list due to the contamination issues it can cause at the MRF level, but obviously like light blue, green, and browns all have some outlet in today's recycling facilities, but for instance, a white PETE package can cause large issues with contamination. So we try to stay away from colored PET when possible. This is just a continuation of the previous list, like I mentioned before, and you can see PVC is listed here as well as acrylic and ABS. We've also taken a do not use stance on PLA and other food or bio-based resins that are coded as number 7. And this is because of limited availability at the end of life. Consumers now don't have access to industrial composting facilities, and since number 7s are not widely recycled, these materials most likely will end up in landfill or contaminating a current recycling stream. And again, here's a list of more materials that we should not be using. And you can see there's nylon, EVA is on here, virgin or SBS board are all listed. We've also taken a do not stance on the degradable or compostable materials. And again, this is because of limited availability at the end of life. Most consumers now don't have access to the industrial composting facilities or composting in general. And as a whole, consumers don't fully understand these green claims, which can cause confusion. So in the end, most of these types of materials will end up in the landfill or contaminating current recycling streams. And like I've said before, we try to focus our design process on what the end-of-life scenario is for a consumer today and what they have available to them, so our packaging has the best chance of being recycled and not ending up in landfills, and hoping in turn it would feed back into the recycled resin market that we currently purchase today. And as you just heard, we've set really lofty goals for ourselves from a materials standpoint, but we also have limitations on the type of inks, coatings, additives, and decoration techniques we can use. And of course, there are instances, again, when our packaging may not meet all of our standards, but this is our ideal state, and as there are innovations in this area as well, we continue to evaluate and update as needed. And our preferred list has been put together for a few reasons. They minimize environmental footprint through total use, energy used in the process, VOC content, etc. And as you can see, we prefer to use pressure-sensitive labels, which can be easily removed during the recycling process, heat transfer labels, embossing or debossing, UV inks and coatings due to the fast cure time, as well as in-mold finishes to cut down on a secondary finish operation. For instance, the package that I had referred to at the beginning of the presentation, we actually included a more of a matte finish in the injection mold, so we kind of could create like a soft touch look to the package without having to do a soft touch finish as a secondary operation. And obviously that also cuts down on cost as well. The decoration techniques that we should not be using have been placed on this list because they have the potential for a negative environmental or social impact. And for example, it's like screen printing on rigid containers can contaminate the recycling stream, as it is difficult to separate the inks from the resin, as well as traditional hot foil stamping creates a lot of waste during the decoration process. And you can see there's other, we've listed other things on here, such as vacuum metallization, UV metal inks, solvent-based inks, phenolic coatings. A lot of these have, negative or are viewed to have negative environmental impacts. And the last part of our list contains, newer degradable additives like the oxo, photo, and hydro degradable additives that can be placed in a resin. And these are also on our do not use list, mostly due to the contamination issues that it can cause within the recycled resin stream. And so there's like a pretty big, we have a pretty big initiative here that if it can contaminate a current recycle stream, we try not to use it, or if it can't be recycled, we try not to use it. And granted, there are limitations when it comes to pumps, because pumps are mixed materials and other packaging components, but we do what we can to ensure that the consumers have some sort of outlet, whether that be a take back program or their curbside recycle bin. Next slide, please. We've also developed a few metrics and usage charts for PCR content in our packaging. And we have these charts broken down by cosmetic and OTC products. So this chart you can see is actually for our cosmetic business. And this chart breaks out the minimum PCR content we theoretically should be using internally for different package types and material types. So for instance, I apologize, this chart and the next chart are both kind of like an eye chart, but you can see, for example, if we make a PET bottle, that we should be using at least 80% PCR, and that is a pretty high amount of PCR content. But we looked at our overall portfolio and said, what are all the PET bottles that we're using today? What is the current amount of PCR content that we're using in each of these bottles? And the average was 50%, and most of our bottles were actually using 80%. So we set 80% as the minimum that we should be using going forward. And then you can also see that if we were to utilize a paperboard secondary packaging, the paperboard itself should contain at least 35% PCR. And we also have an internal standard where we've consolidated most of our paperboards to 4 boards that are used, throughout the industry. And so we don't have a variety of paperboards that we pick from. We have 4 standard boards that meet our sustainability requirements today. And if we do want to use a different board for a different reason, say marketing wants, more appeal at shelf, a whiter board, or a board that has some sort of more like tactile finish to it, we have to vet that out and ensure that it meets our sustainability standard before we incorporate that into our portfolio. And these charts have been created as just a quick reference guide for our business. We're able to gauge whether or not we're meeting the standards we have set for ourselves just based on these quick charts. Next slide, please. And this chart breaks out the minimum PCR content we should be using for our over-the-counter products, and these are products that we make, drug claims against, like sunscreens and, any sort of lip balm that has a benefit to it. For example, if we want to make a product package in HDPE, whether that's a bottle, tube, or jar, we would require 50% PCR. And this can be achieved by, extruding a tri-layer structure where the PCR is sandwiched between 2 layers of virgin material. And we do have some of our packages today that include this technology. And most of other packaging structures, we don't require PCR content due to the guidelines around the direct contact of PCR with an FDA-regulated item. Although you can see with the secondary packaging that we still require the same amount of PCR as we do in our cosmetic products. So once you get into the secondary packaging, whether that be a carton, a tray, a case, a label, a hang tag, that we still require a high amount of PCR content in that paper for that product. Next slide, please. So I want to let everyone know who joined today that we have yearly reviews of our packaging standard to discuss any changes that should be made on material or recovery innovations. And if anyone has any feedback or information they would like to discuss, I'm really happy, to reach out to me. I'm always excited to hear what we can do, to design recyclability into our packaging. And I apologize for the short presentation, but our standard is actually a lot longer than this, but we can only share out partial of it just due to confidential information. So again, just want to thank you for your time, and that, I sort of open up to questions now, but it's just really great to have the opportunity to share out our standard with more of a broader market or people who might not, have visibility with this every day. Okay,
thank you, Jenny. I apologize for not being in sync with your slides there, but I can fix that during the editing process. Again, this has been recorded, and an edited version will be made available for viewing. And I see a couple folks were not able to see the slides. I'm not sure what happened there, but again, we'll have this recording available for viewing. So we're now going to field some questions for Jenny. If you do have a question, please use the GoToWebinar dialog box, and we have a few here already. This question asks, how do you communicate which should not be used in the internal organization and/or vendor partners?
So we actually have, for new hires, we actually have a training process that our R&D group hosts with mostly marketing and anyone else who really wants to join. And we definitely go through this standard and make it a huge part of their onboarding process, so they are well aware of what we're able to use and what we're not able to use. And when we do have new hires coming from all sorts of parts of the industry, this is not first nature to them. And unfortunately, this is first nature to me because I've been working on this since the beginning of my career. But most people don't understand the difference even between simple as PET versus HDPE, and why we make certain decisions. So it's definitely part of our onboarding process. So yeah.
Okay, I have a question. A few slides back, there was the list of contaminants, and I saw calcium carbonate. I see that a problem with other recyclable materials. What is exactly the issue with calcium carbonate?
So from my interaction with calcium carbonate, it's an additive that can be used in HDPE or even polypropylene that can cut back on the amount of resin you're actually using. It can be used as a filler to cut down on costs. We used it in one of my projects to help with the injection molding process, such as help with the processing of the PCR. The issue that comes into play is that calcium carbonate is a really dense material. So when you add it into a resin, it can change the density of that resin. And if that resin does, go through a normal recycling stream, a sink float method, or whatever the recycling facility or MRF has available to them, it can change its density. So it could, if you go over one or go under a certain density, that the HDPE or polypropylene could be lumped in with resins that could contaminate a resin stream that it shouldn't be in. And so we have to be really careful when we use that, when we use these fillers, so we don't alter the overall density of the resin so it can still get separated and recycled properly.
This question has to do with price variation between the virgin and PCR packaging. I guess the resins or the raw materials. I don't know if you want to comment on that. I guess it varies from commodity to commodity.
Do you have a more specific question, or was that just kind of a general?
What can you say about the price variation, if there is one, between virgin and PCR packaging?
There's definitely a price variation, and we deal with that on a fairly regular basis. But our business has made a commitment to pay the increase in commodity costs for the sake of, using recycled materials. And so our business is well aware of that, and we're on board with paying the extra commodity costs for the PCR resin.
Okay. What inspired your company to go to this route? Are you seeing more companies putting emphasis in this area?
Well, what inspired us to do it is, because we're trying to do the right thing with packaging. We started this, I would say it's almost been 7 years ago. I mean, it's been probably a lot longer, but we've gotten really heavily involved into this about 7 years ago. And I think it just keeps us honest, and we're trying to do the right thing by including recycled materials in our packaging, or just making our packaging more readily recyclable. And I think a lot more companies are moving to these types of models, and whether their models include maybe trying to do something like a PLA resin, where our stance is a little bit different in that we try to make sure consumers have an outlet. Because we could, make a bottle out of PLA just to say that we are making a bottle out of, not out of oil, for instance, or not out of, traditional plastic. But, we want to make sure that that bottle does have an end of life and it doesn't end up in a landfill. So I think more companies are starting to realize that something needs to be done, especially the fact that everything does come in a package. So that package has to go somewhere, whether it's in a landfill or it can be recycled. And I think there is a lot more emphasis being placed on just trying to divert resources from the landfill if we can, because everything is worth something. So if we can divert, a new resin from the landfill that can be sold and repurposed somehow, there is money to be said in that. So.
Okay. How easy or hard, does this policy/commitment raise the overall cost of the product line?
Not that I'm aware of. We try to build it into our costs up front. There are times where we do have to make compromises, and we know that. But we do try to build this into our costs up front, so it does not impact the overall cost of the product.
How easy or hard is it for you to acquire all the PCR that you need? Is it easier to procure, for example, PCR Content paperboard? Is it easier to get PET or others?
So it's a lot easier to get PCR and paperboard. It's also a lot easier to get PCR and PET as well as HDPE. We've had some issues, especially recently with a few of our products, getting PCR polypropylene. It's just not as readily available as some of the other, PET and HDPE, because those do come from other sources. Polypropylene, I think, is just now more up and coming with its recovery rates. And so it's definitely a lot easier to get PET, HDPE, and paper recycled resins versus like a polypropylene PCR.
Have you considered that most of your lip tubes can't/aren't recycled in a residential recycling stream due to how small and will be landfilled anyway? Why isn't Burt's concerned about using compostable tubes? So if it does get into the environment, there's less harm than a plastic tube.
So we are well aware of that the smaller items like our lip balm packages, as well as, I think also our lip crayons are made with polypropylene. We are well aware of that, and we do have take-back programs for our lip balm tubes. I believe we have a website up where you can send in your lip balm tube to have it recycled for you. We have looked at compostable type lip balm packages in the past, and also our formula, you have to have something that protects the formula as well, and these compostable packages have not protected our formula as well as the current polypropylene stick. So we are always looking at innovations in market and doing, kind of work up front to see if our formula and the product package interaction works, and sometimes it does and sometimes it doesn't. So at this point in time, it's kind of the best option that we have. And we've also looked at even trying to make our, trying to include a high amount of PCR content in our lip balm sticks. And that's something that we're continuing to work every day, just to try to make our stick as sustainable as possible, knowing that, if this does not get recycled, that there is at least an outlet for it for the take back program.
This is a related question, focusing on recyclability. The newer single stream facilities, recycling facilities, have the screens at the front of their operation. A lot of the smaller stuff falls through right away and goes to the residue stream. Have you looked at that at all, and are you working with any MRFs on that issue?
So we have looked at that in the past, and we are aware of that. We haven't worked directly with any MRFs, but we definitely have a really good relationship with our local around our headquarters. So we've toured, their MRFs and their sorting facilities to understand, exactly what goes on and, what could be done to kind of pull these out. But we are aware that, these smaller packages just don't get recycled at the rates that, soda bottles or laundry detergent bottles do. And so we're working on it. Kind of why I mentioned before that that's how we created the take back program for your lip balm sticks. So there is a way for you to dispose of it without throwing it in the trash, or, so it doesn't just fall through the screens at the recycling facility.
Okay, this question is kind of deep. You mentioned that an environmental preferred option is available. PCR costs don't override this, nor do aesthetics. How do you frame the aesthetic compromise discussion, either internally or with your consumers?
So internally, we do testing, and so we have to have a reason to believe that, using, I'm just going to make this up, but for using, a white PET bottle is going to either, have a better price perception, is going to draw someone to buy the package than a clear bottle, or for instance, it has to have a reason that it's protecting the product in some way from, UV damage or anything else. And so we have to have a real reason in order for us to break our standards. And for instance, another project that I'm working on currently, this package had a lot of different materials in it that are on our do not use list. And so we've spent, 6 months doing line trials to find other materials to replace these materials with. And we've added that into our timeline, and we had to go back to our leadership team and say, I'm sorry, we've tested, X, Y, and Z, and, none of these resins are working out. What is the call? Like, who's going to make the decision on whether or not we move forward with the project? We find a different package. And so we have to have those tough conversations, and they just don't make a decision based on, because someone thinks of something. We actually do consumer tests and have to have data to back up our reasoning on using, or veering from our use list or our acceptable list.
Is there anything you can think of that government can do to reduce the impact of product packaging?
Oh, that's a tough question. What the government can do.
I mean, could they adopt a packaging standard or mandate one? That's a good question, I think.
I'm sure. I'm sure they could. They could start mandating certain things that companies have to do in the packaging world. It's just, I think, on the disposal side, our packaging industry is changing so fast and so often that the recycling facilities can't keep up, and they have to have a reason to invest money into new equipment, and and just like it's a lot of, for instance, going from a milk jug to a flexible package. A lot of flexible packages are becoming more popular these days, and there's just not an outlet for those. I mean, those go directly into the landfill. I understand it cut costs in terms of transportation and size, and but when there's no outlet for these, they just go in the landfill. It's kind of a toss-up. It's like, do you use a bottle that takes up more space and is heavier that can be recycled again, or do you use something that's thinner material, smaller, but goes into a landfill? So I think there are things that the government can do. What those are, I don't know.
I'm going to try and reframe this question. This is about the parent company, Clorox. What is their influence on your sustainability/environmental objectives?
They obviously are all for it. That, we are definitely a different part of their company, so we're a different brand, a very different brand than their other brands that they own. And so they fully back us, and they are well aware of our standard. We actually work closely with other folks within their packaging R&D group to, like, these are our standards, and they're really high standards. And so they also try to, learn from us. They're like, okay, what did you do on this project? How did you combat this issue? What board are you using here? Oh, why are you using that board? And, so we have a lot of conversations back and forth between, the Burt side and their other companies to really help each other learn and to all become more sustainable and more conscious in thinking when we're designing packaging.
Okay, great. I think we're out of questions. I think that's time to wrap up. Thank you for the audience for those great questions, and thank you, Jenny, for the presentation and the Q&A. So we're now going to close the webinar. In closing, again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thanks again for joining us. We hope you'll join us for next month's webinar. And please visit the NRC and RMC websites for schedule updates. Thanks again, Jenny. I really appreciate it. And thanks for your time on this. And so long, everybody, and have a great day.
Yep, thank you.